Today, we'll be going over a physically accurate but simplified conveyor system that worked with physics actors. All right, let's go ahead and get into the overview. Within the viewport, we have a few scene components, one being the parent of the physics collisions, and then one being the parent of all of the visual elements, such as the floor and the walls. Within the construction script, we're first scaling the actor back to its original scale to make sure people aren't accidentally scaling the actor inappropriately. And instead, we have a size variable to scale the conveyor system with. And this is scaling both the collision object as well as the visuals. Okay, let's head on over to the main function. The first thing that we're doing is we're resetting the location, and then we're doing what is called flip-flop. We then set the physics override material and go to the next node, which is move component 2. We will be moving the component over a series of time, and then over in the B section of flip-flop, we are simply resetting all of the values. And over at the sequence, you want to make sure that 0 goes to return and 1 goes to stop. Let's go ahead and zoom everything out for the overview. Okay, so that should be it. Okay, let's get started. So the first thing you want to do is create a new blueprint class, make it an actor, and name it physics conveyor. And now go ahead and open up that blueprint. We are going to be adding a few components, the first one being a scene component for the movement of the physics object. We're then going to add the actual conveyor collision object. Let's go ahead and call that collision conveyor object. The next thing we're going to be doing is changing the scale so that it looks a little bit more like a conveyor platform. And after you have it in a scale that you like, we're going to create a new variable and name it size. This is going to control the length and the width of the platform. We're going to make it a vector2 and make it instanced editable. And this will allow us to control it in the viewport of the editor. Within the construction script, we're going to set the actor scale, and it's going to be set to 1. And that will reset the scale just to prevent people from scaling the actor. And what that's going to do is force them to use the size variable. So let's set the relative size of the movement helper, and we would be using the size XY variable that was made. And for the Z scale, we're just going to keep it a small number right now, just to keep it looking like a platform. So within the viewport, you can see that this is working for the length and the width, but it is scaling from the center, and we want it to scale from the edge. Let's go ahead and move the collision object over so that it scales properly. And then we're going to move over to the event tick. Within event tick, the first thing we're going to do is reset the location of the movement helper. We're going to use a flip-flop to switch the instructions every other tick. The next thing we need to do is create a physics material object. So click on physics and then click on physics material. For this physics material, we'll call it 0 friction. And this material is going to have 0 friction and it's going to have 0 restitution. Let's go ahead and head back over to the blueprint. So for A of flip-flop, we're going to set the physics material, and we're going to select the 0 friction material that we just created. The next thing we're going to do is use the speed variable and have a node called move component 2. So for the relative X location, we're going to be plugging in the speed and having the Y and Z be 0. And we're going to set 1 second for the time. And then make sure the movement helper is the component we're going to be moving. Over in the B section of the flip-flop, we're going to be setting the physics material to a rubber material. We are also going to be setting the movement component's relative location back to 0. We are then going to do a sequence. The first branch, we are returning everything, and then the second branch will stop it. And that should be it for the main functionality. So let's go ahead and see what happens in the viewport. As you can see, we can change the scaling. Let's go ahead and then add a cube and make it simulate physics. You can see that the cube is actually traveling in the wrong direction from what we want it to go. So let's go ahead and fix the issue. So back over in the blueprint, where it says move component 2, we need to reverse the speed by multiplying the speed by -1. So that should fix the issue we were seeing. And as you can see, it is now going the correct direction. And now zooming in, you're going to notice that there is some jittering because it's moving back and forth. So instead of showing the actual collision object, we are instead going to create a few visual components and then hide the collision object. Let's go ahead and duplicate the collision object and move it over into the visuals scene component. For the collision object, you're going to make sure that it is hidden from the game. Because we want the visuals and the actual collision to have parity, we want to make sure to scale both of those inside of the construction script. Make sure that the visual for the conveying platform doesn't have any collision. For this tutorial, I'm going to create a couple of basic walls. These definitely can have collision. But with that said, you want to make sure that the collision object, any visibility checked. Okay, let's go ahead and see it in the viewport. It looks like everything is moving. You can change the length and the width, as well as the conveyor speed. And so it's all performing as expected, and the tutorial is over.